ATP paper 62 IGCSE Physics 0625 of February-March 2026. This paper should be completed in a duration of 1 hour in your exam, and the instructions are written over here. So we have to answer all the questions. We have to use a tab with pen, and we may use an HP pencil for any diagrams or graphs, which we are going to shortly see in the paper. Similarly, we are not allowed to use an erasable pen. We cannot use correction fluid or tape, and we don't have to write on any barcodes. And the use of calculator is allowed. We have to show all the working, and we have to use appropriate units. The total marks for the paper are 40, and individual marks will be shown in front of each part. Now, while I'll be explaining and going through the paper, I will not only explain how to write the answer to a question, but also the ATP paper is a sort of a do-as directed paper. So the first thing is, and the most important thing is, we have to read the paper very carefully. We need to understand each and every statement, and then connecting all the pieces of information, we have to make a picture in our mind that what is being asked and how to answer all those things. So reading, understanding, and comprehending the question is the first and the most important thing which we need to keep in our mind. And secondly, I will also be explaining during my walkthrough of the paper that what are the incomplete and vague answers for this type of paper or these types of questions, which are not going to score good marks for us. And sometimes we may not be able to get any mark for our answer. So keep in mind that which answers are to be avoided and which ones are to be written to gain full advantage and full marks for a particular question. So let's start with the question number 1. It says, a student determines the density of a glass ball. So what he's doing something to find out the density of a glass ball. And we know that the density of a substance is found by taking out and finding two things, mass of the substance and the volume of the substance. So the student has glass ball, and he or she is trying to find the density of a glass ball. So the method is being used is, the student pours water into a measuring cylinder until it is approximately half full. Then places the measuring cylinder of water on a top pan balance so that the mass of the measuring cylinder with water could be recorded. Records the combined mass M1 of the measuring cylinder and water, and the reading of the mass is given to be 125.6 grams. Now, part 1 says, describe one technique for using a top pan balance to measure the mass of the measuring cylinder and water to ensure an accurate reading. So we have to write down any one technique to answer this question. So first of all, whenever we are using an instrument to measure something, the first and the most important thing is that the instrument must be zeroed before taking any of the reading. So I could write the answer as, ensure the balance is 0 before taking any measurement, or it is cleared before placing the measuring cylinder on it. This is the most commonly accepted answer here for this type of question. The other answer which we could write here could be that we need to check the balance, that it is on a level or flat surface. So the other answer could be, the balance is placed on a flat surface. So that will also ensure that the mass of the measuring cylinder is calculated correctly. And we could also write down that we have to wait for the reading to stabilize before recording our answer. So any one of the points could be written over here. Now, which answer to avoid writing such answers? So if a student writes here, if a student is going to write the answer like read carefully, read the reading carefully. So this is something which is a vague answer, and it is not going to score any marks. So whenever the examiner is asking about technique for using a particular instrument, So the technique to be written must be specific, and more importantly, it should be actionable. It should be something doable. So we have to be specific, and we have to write an actionable item to answer such type of a part. So any one of the actionable and specific thing will earn us 1 mark in this part. Now the second part says figure 1.1 shows the water level in the measuring cylinder. So this is the measuring cylinder, and we can see that there is a meniscus here. There is a bottom part of the meniscus, and there could be an upper part of the meniscus as well. Now record the volume V1 of water in the measuring cylinder. Whenever we are recording and there is a meniscus in the question, so we always read the bottom of the meniscus. We never read the top of the meniscus, otherwise it is going to give us a wrong answer. Now reading it, we can see that this mark is 80 and this one is 90, and from 80 to 90 there are 10 graduations. So means every graduation is representing 1 centimeter cube. The unit is also mentioned here. So it is 90, and the one above it is 91 centimeter cube. Now whenever we are measuring, it is advisable to use a scale and place it over here in your exam paper and see where the reading is matching and which graduation has the lower or the bottom of the meniscus. Make sure that you read the correct graduation and then you write the answer. So we read the bottom of the meniscus and it came out to be 91 centimeters cube, and centimeter cube, the unit of the volume, is already written there in the answer sheet in the question. Okay, describe 2 techniques that the student uses when measuring the volume of the water to ensure that an accurate reading is obtained. Now again, we are asked about 2 techniques. They should be specific and they should be actionable. Vague answers and generic answers will not be acceptable here. So one of the technique, the first and the most important one, could be that the student should read the scale at eye level. And reading the scale at eye level means that the line of sight of the student must be perpendicular to the scale. Like if the student is going to read this reading, his eye should be placed in a way that it should be perpendicular to the scale. This is how the line of sight should be placed at the point from where the reading is to be measured and recorded. So this is the first thing that the student should be careful about. And the second thing is the student must read the volume from the bottom of the meniscus. If the student reads it from the top of the meniscus, again, that is not going to be an accurate reading. The next part says the student places 4 glass balls into the water in the measuring cylinder, ensuring no water splashes out. So this is done very carefully. The student records the mass M2 of the measuring cylinder, water, and the 4 glass balls, and this comes out to be 132.8 grams. Calculate the mass M of 1 glass ball. Okay, for calculating this answer, the first thing that we are going to do is we need to find, or we can find, the mass of 4 glass balls. And this would be simple. We have the mass M2, which is giving us the mass of measuring cylinder, water, and the 4 glass balls. And previously we were given with the mass of M1, which was only the mass of the measuring cylinder and the water. So what we are going to do for finding the mass of 4 glass balls, we are going to subtract M1 from M2, which is 132.8 minus 125.6 grams, and the answer is going to be 7.2 grams. This is the mass of 4 glass balls. Now, if we are going to find the mass M of 1 glass ball, for that 7.2 should be divided by 4, and the answer will come out to be 1.8 grams. So gram is already written over here. I'm going to write 1.8. This is going to be the mass of 1 glass ball. The next part says the student records the volume V2 of the water and the 4 glass balls, and it comes out to be 94 centimeter cube. Calculate the volume of 1 glass ball. We can find the volume V of 1 glass ball in the similar way, and that is, first we are going to perform a subtraction. The total volume of water and 4 glass balls, which is given as V2, and there was another volume given, which we read from this figure, and it was the volume of water in the measuring cylinder, only the volume of water. Okay, so if we subtract the volume of water from the total volume containing water and the 4 glass balls, we are going to get the volume of 4 glass balls. So 94 minus 91 will give us an answer of 3. Since this is the volume of 4 glass balls, so if we divide it by 4, we are going to get the volume for a single glass ball, which is going to be 0.75 centimeters cube. And the answer in the answer space should be 0.75 centimeters. So this is how in both of the calculation questions, we have to show the complete working, and every operation should be shown, whether it is subtraction, division, and all those things should be clearly stated here. Now the next thing is we have to calculate the density rho of a glass ball. Use your answer and your values from question 1 part B part 1 and 1B2 and give the unit also. Use the equation rho is equal to m upon b. Now the mass of the one glass ball, it came out to be 1.8 grams, right? And the volume of one glass ball, it came out to be 0.75 centimeters cube. And the answer for this division comes out to be 2.4 grams per centimeter cube. So the answer for rho is 2.4, and the unit with the answer is grams per centimeter cube, because the mass was recorded to be in grams and the volume was given to be in centimeter cube. Okay. The last part of the question says, suggest 2 improvements that will help a student to determine a more accurate value for the volume of a glass ball. Now, we again have to show 2 improvements which should be specific and actionable, and no vague answer should be written over here. And these 2 improvements should be done to determine a more accurate value for the volume of a glass ball. So the first thing is, since the volume was being calculated using a measuring cylinder containing water, so the first thing that we could write over here is use a measuring cylinder with a smaller scale division. Using a smaller scale division is going to give us a more accurate answer. For example, 1 centimeter cube scale should be used, or the division cylinder should be used, instead of using a 2 centimeter cube division cylinder. So using a smaller scale is going to further improve the reading. The second technique that could be used here is the student used 4 glass balls. So for further improvement and greater accuracy, we could use a greater number of glass balls, and this is again going to further improve the results. Another point which could be written here, that we state here, and this is an extra point, just for the sake of further explanation, I'm going to write it, that we could use a burette instead of a measuring cylinder. This could be one of the points which is, a strong point which could be written here for greater precision. So any of these, out of these 3 points, any of the 2 points are going to score full marks here. If someone writes that we should use a scale to measure the diameter of the ball, and then we could use 4/3 pi r cube to find the volume of the glass ball, that is also an alternative method which could be used, and this will also score 1 mark here. So this would be the 4th option to be written here. Moving on to question number 2. Question number 2 says, a student investigates the behavior of a spring. Refer to figure 2.1. Part A1 says, describe 2 techniques the student uses when measuring the length of the spring to ensure an accurate reading. You may draw a diagram as well. Since the instruction is you may draw, so it is not compulsory to draw the diagram, but if the diagram helps our explanation, then we can draw it. So the first thing, again, we are going to read a meter rule over here. So the first thing which we have already written in the previous question could be repeated here, that we should position eyes at the same level as the scale marking. So placing the eye at the same level would make us avoid the parallax error. So we have to place the eyes at the same level as the scale marking when reading the meter rule. The second point would be that ensure the meter rule is positioned vertically and parallel to the spring, so the scale is alongside the measurement points. Another point which could be written here is that we could use set square to take the reading accurately. Placing a set square in a correct way is going to make sure that the reading is being taken correctly and there are no mistakes in taking the reading. There could be some vague answers which could be written here, like if someone writes that measure from top to bottom, or answers like this, incomplete answers, they are not going to score any marks. So we have to write such 2 points which are specific, actionable, and related to the situation. And if you have to draw the diagram, you should be making a set square to make it further clear that how the reading could be taken in an accurate way. Now the next part says, using figure 2.2, record the initial length and knot of the spring with no load. Do not include the loops at the end of the spring. So they are talking about these loops. They should not be taken into account in your measurement. Show clearly on figure 2.2 how you made your measurement. So for taking the measurement, what we are going to do, we are going to make 2 lines here. So for measuring the length of the spring, I've drawn 2 lines here. The first one is coinciding with the mark 36.3, and the second one is giving us the reading of 38.5. So the length of the spring is going to be 38.5 minus 36.3, which is equal to 2.2 centimeters. Remember, these readings are in centimeters since we are using a meter rule. Now we have to record the answer here, and the unit here is millimeters, so we have to convert it into millimeters. For that, we are going to multiply it with 10. So our answer is going to be 22 millimeters, which is to be recorded here, and knot, which is the original length, is 22 millimeters. Now the next part says, the student suspends a load of 1 Newton from the spring, records the new length L of the spring in table, calculates the extension x of the spring using the equation that extension is the new length minus the original length, records the values of x in the table, repeats the procedure using the loads of 2, 3, 4, and 5 units. Now we have to complete this table. Remember, the extension is the new length minus the original length, and the original length is going to remain constant. So 42 minus 22, which is the original length, is going to give us an answer of 22 millimeters. 61 minus 22 will give us an answer of 39. 82 minus 22 will give us an answer of 60. 107 minus 22 will give us an answer of 85. And finally, 125 minus 22 will give us an answer of 103 millimeters. So this is how the table is to be completed, and it will earn us 2 marks. The next part says, now this is a graph question. It says, plot a graph of load in newtons on the y-axis against extension in millimeters on the x-axis. Second instruction is, start the axis from origin 0, 0. And the third instruction is, draw the best fit line. Okay, so for every graph question, the first thing that we are going to do is we are going to label the axis. So the y-axis would be labeled as load in newtons, and the x-axis should be labeled as extension in millimeters. Once you label the axis, you are going to get 1 mark for it. Now, the second thing is we have to scale the axis. So for load, it's simple, 1 to 5, and the number of boxes we have 1, 2, 3, 4, 5, and 6. So we have to start it from origin as was the instruction of the examiner. So this is 1.0, 2.0, the next one is 3.0, 4.0, 5.0, and the last one is 6.0. Now for the x-axis, the minimum value is 20 and the maximum is 103. We have 1, 2, 3, 4, 5, 6 boxes again. So again here, the x-axis and numbering should start with 0. It should be 20, 40, 60, 80, 100, and 120. So once you scale the axis, you are going to get the second mark. The scaling should be done in a way that more than 50% of the grid should be used in making the graph. So if it is more than 50%, you are going to get the mark anyway, and it's better to use the maximum of the grid while we are scaling. The scale should not be awkward, and it should be in the graduation of 1 or multiple of 1 or 2 or 5. These are the normal scales which are accepted. Using an awkward scale like 3, 7 or something like this is not going to be acceptable in the exam. So we have to keep this thing in mind. Now, the third thing is we have to plot all the points. So the first one is 1 and 20. So if we are plotting a point, one way of plotting is that we have to make a thin dot and then encircle it to highlight the point. That's where it is actually marked. The second thing that we could do, we could make a cross with a very thin pencil showing each and every point. The second point is 239. So for a load of 2, now remember these 10 boxes are representing 20 millimeters. So 10 boxes are representing 20 millimeters. So one box represents 2 millimeters here. And the mid of the point is going to represent 1. So this one is going to be 38, this is 40, and in the middle of them, there is going to be 39. So I'm trying to mark a point very carefully in the middle of this box, and this should be the second point. Now the third point is 360, which is relatively simpler. So it is going to be here at 360. Now the next point is 485. So 485, remember this one is 90, and the middle of 80 and 90 is going to be 85. So again, I'm marking a point at the center or in the middle of the box. The last point is 5 and 103. So 102 and 104. In the middle of them, there is going to be 103. So this is where the point should be marked. So now when we are done plotting all the points, we are going, and if we have plotted them correctly, we are going to get 1 more mark. So far we have done the work of 3 marks. Now the last instruction was we have to draw the line of best fit. So I'm trying to align the scale in a way that the line of best fit should be drawn here. Okay. So for drawing the line of best fit, it should be done in a way that the maximum points should be on the line, and the ones which are not on the line, they should be distributed equally above and below the line. So this should be the line of best fit here, which is going through the maximum points, and the points which are not exactly located on the line, they are above and below, they are distributed above and below the line uniform. So this is how we are going to earn 4 marks from the graph. Let me name the steps again. The graphing starts with labeling the axis. 1 mark is awarded. Then scaling x-axis and y-axis. 2nd mark is awarded. Plotting the points correctly. 3rd mark is going to be awarded. And then following the instruction, whether it is a best fit line or a curve, we make a graph, and the 4th point is awarded for making a correct or the accurate line of best fit. Now, the last part of the question says, state and explain if your line shows L and X are directly proportional. So obviously, it is showing that these 2 quantities are directly proportional because the graph is a straight line, and it had to be a straight line. And secondly, the straight line is passing through the origin. So if your line of best fit is passing through the origin, then only we are going to conclude that they are directly proportional. Otherwise, we can say that they are not directly proportional if the straight line is not passing through origin. So we can say that they are linearly related but not directly proportional. But here in this case, we are writing yes L and X are directly proportional because, and now we have to state the reason as well. The best fit line is straight and passes through the origin. That is why we have said that they are directly proportional. It is a straight line passing through the origin. Moving on to question number 3. It says a student investigates circuit containing different combinations of resistor. Figure 3.1 shows circuit 1. In this circuit, there is a battery, there is a switch, an ammeter, a voltmeter, and there is a single resistor. Circuit 1 contains one resistor of resistance X ohms. The student closes the switch and measures the potential difference PD and the current. Record in table 3.1 the voltmeter, the ammeter, and ammeter readings shown in figure 3.2 for circuit 1. Now, which one is the ammeter and which one is the voltmeter? We have to recognize it by seeing the unit. So this one is ammeter, which has a unit of A, amps, and this one, the second one, is a voltmeter. It has a unit of V, volts. Now, for voltmeter, we can see that there are 10 graduations between 2 and 3. So every graduation is 0.1 volts. So the reading is 2.4 volts. For circuit 1, it is 2.4. For ammeter, we can see that there are 10 graduations between 0 and 0.2. So every one graduation is 0.02. So keeping this in mind, this is 0.22, 24, 26, 28, 30, and then 32. So the current has a value of 0.32 in the figure. Okay, after recording this, it says figure 3.3 shows circuit 2. Circuit 2 contains 4 identical resistors, each of resistance capital X. The student closes the switch, measures the potential difference PD and current, and records again in table 3.1 the voltmeter ammeter readings shown in the figure 3.4 for circuit 2. This time the voltmeter shows 2.3, okay, and the ammeter is showing 0.30. Okay, so I'm going to record it again. The voltmeter reading was 2.3 and this was 0.30 amperes. Now, calculate and record in table 3.1 the resistance of each circuit. Give your answer to 2 significant figures. Now, the instruction is we have to give the answer to 2 significant figures, so we'll follow it. If the instruction is not clearly given, then we have to see the raw data or the recorded data which is there in the question, and we must give our answer matching with the least number of significant figures. If all of them have the same significant figures, then we have to follow the same thing. If the raw data or the given values have different number of significant figures, then we'll see that which one has the least number of significant figures, and we'll follow the same for writing our answers. So use your reading in table 3.1 and the equation shown R is equal to V upon I. So for circuit 1, we have the formula R is equal to V upon I. For circuit 1, we have 2.4 divided by 0.32. And for circuit 2, we have 2.3 divided by 0.30. The first answer gives a value of 7.5 ohms. So I'm writing 7.5 over here. Okay. The second one gives 7.66, which is going to be 7.7 ohms. So it was 7.66, which when rounded off to 2 significant figure would become 7.7 ohms. And all of this working, it should be shown here in the answer space. So I'm copying it down here. That this is the working that we have done for circuit 1 and for circuit 2. And this working is to be shown completely. It will earn us 3 marks. So let me write that this is for circuit 1 and this one is for circuit 2. R is equal to V upon. Okay. Now the question says theory suggests that the resistance of circuit 1 and circuit 2 are the same. This is a suggestion. State whether the results support this suggestion. Justify your answer by reference to the values from your results. So whether the two values are same or they are different, we have to check this by finding their percentage difference. And for finding the percentage difference, the technique or the formula that we use is, so for finding the percentage difference, the technique we use is we take the larger value and subtract the smaller value from it. So this gives us the simple difference between the values. And in the numerator, we consider their average. So the average could be taken when we add the smaller value with the larger value and divide it by 2. And then we multiply it with 100 to give us the answer in percentage form. Now remember, if the percentage difference is less than 10%, then within the experimental limit of experimental accuracy, the two values are considered to be same or equal. But if the percentage difference is greater than 10%, then obviously they are not considered to be equal or same. So the same thing we will be doing here. I am considering the value 7.7 minus 7.5, then 7.7 plus 7.5 divided by 2, taking their average, and then multiplying it with 100, 2.6%, and which is obviously less than 10%. So the statement that we are going to write here is that yes, the results support the statement or the theory. And what is the justification? The percentage difference between the values is less than 10%. So they are same within the limit of experimental accuracy. Okay, the next part says figure 3.5 shows circuit 3. Circuit 3 contains 9 identical resistors, each of resistance X ohm. And remember, for this particular resistance value, we had the first circuit where we worked out the value of this resistance to be 7.5 ohms. Okay. So circuit 3 contains 9 identical. Identical means all of them have the same value of resistance, and each of resistance X ohm, which came out to be 7.5 ohms. Predict the resistance of this combination of resistors. So it means that there are 3 branches connected in parallel, and in every branch there are 3 resistors connected in series. Each one of them has a value of 7.5 ohms, and when the resistors are connected in series, they are simply added to give the overall resistance. So the overall resistance of this branch is 22.2 ohms. The same is for this one, 22.2 ohms, and the same is for last one, 22.2 ohms. Now, for finding the total or the effective resistance, since these 3 are connected in parallel, so we are going to use the reciprocal rule. We are going to take their reciprocals, add them, and this will give us the reciprocal of the total. So 22.5 is going to be the LCM, and the total resistance will come out to be 22.5 divided by 3, which is again going to be equal to 7.5 ohms. So this is going to be the overall resistance of this circuit, where the 9 identical resistors were connected in this way. Okay, another student performs the same experiment but uses a digital ammeter. Instead of an analog one, the student is using an a digital ammeter. State one advantage of using a digital ammeter. Okay, so the first advantage which could be written is it is easier. So it is easier to read accurately as it displays a numerical value eliminating the chances of parallax error. Parallax error is ruled out when we are using a digital ammeter rather than an analog one. Okay. So if someone writes that it is more accurate than analog one and does not write any reason for it, so this will become a vague answer, and the examiner most probably is not going to give any mark for such an answer. So we must give a reason why digital meters, what would be an advantage of using a digital meter over an analog one. Figure 3.6 shows a digital ammeter display which is connected in a circuit. 290 milliamperes is the reading. Read the value for the current shown in amperes. Okay. So in amperes, the 290 should be multiplied by 10 raised to minus 3, or should be divided by 10 raised to 3, and this will become 0.290 amperes. So the answer to be written over here would be 0.29 or 290. Both of them would be acceptable here. The last part says, suggest 2 reasons why the switch is opened after readings are taken. So in electricity questions, the continuous current through the components of the circuit are going to is going to make them overheat. So to prevent the components from overheating, we continuously do this practice that we open the switch immediately after taking the reading. So the 2 reasons, the first one is to prevent the circuit components from overheating, as the excessive current flow causes heating, and obviously heating is going to change the resistance, or it is even going to damage the components. The second reason, which is also very common, be written in the answers like this, that we want to conserve the battery life. If the battery is used unnecessarily for longer period of time, it is going to be drained very quickly. So to prevent the battery from running down between the readings, we need to open the switch and preserve the battery. Moving on to the last question, which is the planning question. So it says a student investigates the rate of cooling of hot water in a container which has a lid. Plan an experiment. So this statement is to be read very, very carefully, because it is going to give us an idea that what are the 2 variables involved in the planning of this experiment, which one is the independent one, which would be changed by us, and which variable is going to be the dependent one, which is to be measured or recorded by us. So it says plan an experiment which enables the student to investigate the effect of different starting temperatures on the rate of cooling. So the different starting temperatures are going to be the independent variables in this particular investigation. So this is independent variable, which is going to be set by us. And the thing which depends on it and which is going to be affected by it would become the dependent variable, and that would be the rate of cooling. So once we have these 2 things in mind, then it is easier to plan and then write down the answer. Now the question says apparatus available includes a beaker, which is obviously would be used to hold the hot water, a measuring cylinder, which would be used to measure the volume of hot water, a supply of hot water, and a lid. In your plan, state any additional apparatus required. Now, we are going to go back to the statement, and we are going to see that what are the 2 variables that we are going to measure. The first one is we have to measure the temperature. So for measuring the temperature, thermometer would be needed. So our independent variable requires us to have a thermometer so that it could be measured. The second thing is rate of cooling. Now remember, the rate of cooling means there are going to be 2 things involved in it. The first thing is change in temperature, which is again going to be measured using the thermometer. And for making it the rate of cooling, we are going to divide it by time. And for measuring the time, we have to have a stopwatch as well. So there are 2 main things which are missing here. The The first one is thermometer and the second one is stopwatch. So this is going to answer the first point of the question. Now, secondly, they're asking, explain briefly how to do the investigation, and we are going to write an answer for that. The third thing, as usual, state the key variables to keep constant during this investigation. The fourth thing is we have to draw a table or tables with column headings to show how to display your readings. You are not required to enter any readings in the table as usual. All of you know that we are not required to put any readings in the table, and obviously we should not be putting any reading until we are practically doing this investigation. And when we are just writing the plan for an investigation, the readings should not be there. Explain how to use your readings to reach a conclusion. This is going to be the fifth point. So I'm starting to write an answer from the first point, and I'll be writing them by making headings so that it's easier to understand that which points are already addressed. So the first thing was we had to write additional apparatus. And there are two things which should be there. So I'm writing them one by one. The first thing is thermometer has to be there to measure the initial temperature and the change in temperature. And the second one is a stopwatch or a timer should be there for recording the time. The second thing was we have to write down briefly the method how this investigation would be performed. So for method and writing, the first point is use the measuring cylinder to pour a fixed volume of hot water into the beaker. Number one. Number two, place the lid on the beaker. Number three, record the initial or the starting temperature. And this is normally denoted by T0 in degrees centigrades using the thermometer. Number four, start the stopwatch or the timer immediately without wasting any time. Number five, record the temperature, or should we say the final temperature after a fixed time interval. For example, we set an interval of 10 minutes or 20 minutes. So after, when the fixed time interval has passed, we will be noting the final temperature, which is going to give us the idea how quickly or how slowly the liquid is cooling down, the hot water is cooling down. Now, the sixth point is we will be writing repeat the entire experiment or all of the above steps using a different starting temperature. The only thing that we are going to change is we are going to use a different starting temperature. The next point we could write here is repeat for at least 5 different starting temperatures so that we can reach a fair conclusion that how the different starting temperature is affecting the rate of cooling. Now, the next point, we have to note down the key variable to be kept constant. So I'm making a heading, variables to keep constant. Now, the variables which are to be kept constant, number one, the volume of water in each observation, it should be kept constant, it should not be changed. Same lid and beaker used throughout the investigation, they should not be changed, because changing their material is going to affect the reading. Then obviously it is a investigation which is related to heat and temperature, so we have to have same room temperature or the temperature of the surroundings so that the results are fair. And the fourth thing is we have kept the same time interval for recording the final temperature. So I've listed down 4 of these key variables. Writing 2 is enough in the exam. Now, the results table, or we can also make more than one table if we want. So the first thing that we will be noting down is the time, and it will be in minutes. The second thing is we will be noting down the starting temperature, which was denoted by T naught, and it will be in degrees centigrades. We will be noting down final temperature after the fixed time interval, and this will also be in degrees centigrade. So these are the 3 main things which will be required for this investigation. And using final and starting temperature, we can find out the change in temperature, and change in temperature divided by the time will give us the rate of cooling. Now the final thing is, how are we going to reach a conclusion for this investigation? So there are 2 methods to write down the conclusion for a planning question. The first thing is we can compare the values in the table and then try to reach a conclusion. The second thing is making a graph. So I'm writing down the method of graph. So first we will be calculating the drop in temperature for each starting temperature, and then plot a graph of temperature drops against time, and there would be more than one graphs on the same grid. So we will be plotting the graphs of temperature drops against time for each tribe on the same graph. Now the gradient of the graph is going to tell us the information about the rate of cooling, and how it is going to show in writing. The steepest or the steeper gradient means a faster rate of cooling. So this is how we are going to conclude that how the starting temperature of this in this experiment is affecting the rate of cooling. So this was a 7-mark answer, and all the things are written here to earn probably full marks in the question. This was the end of the paper. I hope this will be useful for your preparation. I've tried to explain all the answers, and especially which answers to avoid writing when you are attempting this paper. So hopefully this will be useful for you, and I'm ending the class. Thank you.